Yeah, here today to talk about Temporal and Orchestrating, which is this nice system we use for kind of large-scale perceptual AI aesthetic analysis. It's been quite a journey. I'm happy to share this with you guys. So a little bit about me, Eric Ziegler, work at the Washington Post, principal engineer there. I mainly work on video, photo, and some machine learning stuff. You guys can find me on LinkedIn, on Temporal Slack community, or on GitHub. I pop in there every now and then, but if you send me a message on there, it might take me a while to find you. Really quick, I want to talk about what ArcXP is, because often I have to put that ArcXP in front of the Washington Post part, because I find a lot of people are like, the what? So this is a CMS we built at the Washington Post specifically for like media companies. It's meant to kind of address a lot of like long-standing, really painful problems with CMSs and media companies, where you have to cobble together just a ton of vendors to get things working right. You know, you got to get your video vendor, your photo vendor, your article publishing, get your Akamai CDN stuff, all that, and we just built it all into one platform. You know, that's the ethos: is you just use ArcXP, you get your one-stop shop. Yeah, all in one, no plugins needed. The slide covered it. But this is just a screenshot of our marketing website. I think our marketers are much better at presenting the product than I am. You know, you get the engineer perspective versus the market perspective. But yeah, you can see we have some pretty big customers like Gray Television, massive broadcaster, Graham Media Group, Boston Globe, Fox Sports. Reuters isn't on here, but they're another one of ours. But yeah, if you have a media company and getting tired of WordPress, you know, let's talk. But anyway, the central question, though, of this talk is, can a machine tell if a photo or video is aesthetically pleasing? And the answer is yeah, totally. You know, in machine learning, we just mimic what humans do. In this case, we basically figure out, you know, how does a human being analyze, you know, a piece of visual media and decide that looks nice, or, you know, the opposite, that does not look nice. And to address this, we come up with like an aesthetic score from like 0 to 10. And something that's really important with this is, well, I mean, really any sort of like computer vision application, you always have to deal with some level of bias. But with an aesthetic evaluation like this, there's actually some pretty severe risk of bias. You know, for instance, if you trained this off of a data set built off of just one person, right? That's extremely biased. You're only getting that one person's entire aesthetic view of the world. So for this, we do it, you know, simulation via crowd. Basically, when this process runs, you're getting an assessment by, you know, 200, 500 individuals at one time. So it's a big consensus. The process is called Orchestrating. I named it. You know, you give engineers charge of naming products, and well, the company's called Arc, and it does aesthetic stuff, so Orchestrating. That's how it goes, right? But anyway, sorry. So what it's looking for is two kind of high-level pieces. Basically, the first is like kind of an objective sort of scoring, where you're looking at image quality. You know, does this image have like artifacts? Is the data incomplete? Which is a serious problem, you know, with progressive JPEGs. You know, you show it a progressive JPEG that only half loaded, it's going to see that huge gray bar at the bottom, and it's going to give it a really bad score. But as well as that, it will also do an analysis on a more subjective side, which is aesthetics. And it's looking at things like lighting, contrast, you know, a little bit about the subject, composition, these sort of things. Things that like a human being would actually kind of have to look at with a keen eye and, you know, make judgments on. So to kind of make this more concrete, I actually want to get a little crowd participation here, get a concrete example. So I want you guys to put yourselves in the shoes, like you guys are Orchestrating now, and we're going to see how we as a crowd compare to the machine learning model in our assessments. So we have two photos here. The first one is of my lovely dog Frida. I think she's staring at a squirrel in this. And the second photo is a picture of me holding a Nintendo Switch. This picture was taken accidentally while I was trying to dismiss a notification on my phone. So just a quick A/B test, and the criteria is simple. Which one looks nicer? So raise your hand if you think photo A is the nicer looking one. I've seen a lot of hands. All right, what about photo B? All right, we got some controversial opinions here. All right, I like it. Well, so Archaesthetic chose the dog. I think it's pretty obvious why. The second photo actually fails almost every single one of those quality attributes, right? It's bad visual quality, it's bad lighting, bad contrast, the composition is crazy, no centered subject or anything, and it's actually hard to tell, speaking of composition, but there's a cat in the lower left corner, and if I hadn't pointed that out, I don't think most people would know. Bad composition. But this is kind of a trite example, so let's do one a little bit harder. So these are my cats, Binks and Patches, and no, I did not submit a presentation just so I could show you guys photos of my pets. But yeah, let's assess this one. Show of hands, who thinks A is the superior photo aesthetically? All right, what about B? Okay, see that's a little bit tighter there, but we did pick the same one as the model. And this one, I think, there's two actual reasons why. Visual quality-wise, these two photos are very similar. There's no artifacting, nothing like that. Same lighting, same contrast. So it actually came down to a composition problem. And the first obvious piece of the composition is, Patches, the calico cat, is looking at us in the second photo. That's more desirable most of the time, unless, she was looking away doing something really cute. But in this, it kind of looks like she's just looking at the other photo. But the other more subtle thing that the AI picked up on, and it's maybe a little bit hard to see on the screen, but photo A is actually just slightly askew. You'll probably notice it if you take a look at the step that they're standing on. Very, very slightly askew. It's almost like a 2% grade. And the model picked up on that and said, oh, well, this is a composition failure. It's not level. You need to crop it. Yeah, so that gives an example kind of concretely what it's looking for. And we actually use this quite a bit for video. And in the video realm, there's a ton more visual data to work with. You have, with a photo, you're just ranking a single item, but with a video, you think about it, you have like your 29 point whatever frames per second. You have maybe 60 minutes of video. That's about like 100,000 frames to look at. Obviously you're not going to look at all 100,000 of them, but it's a lot more visual data. So in this case, you tend to take a distribution of the scores and examine them. And this leads to really interesting use cases. One of my favorites that we've experimented with is doing kind of an automatic A/B testing for encoding quality. Traditionally when you're figuring out maybe a new codec setting for your video, you'll pump it out and run it through PNSR, get your PNSR score, and PNSR is pretty good, but this also gives you the added benefit of just this automated way of like a human looking at it and be like, yeah, it looks good. The encoding settings work right. But yeah, so speaking of video, I want to talk about thumbnails really quick. So thumbnails are super important for videos. If you ever scrolled YouTube and you see all the different influencers, you got like Mr. Beast, like, it's a big deal. Thumbnails are really important because you only get one chance to make a good first impression and like draw your audience in, and you do that by conveying your message quickly via the thumbnail or making it like enticing in some way. So if you're a small operation, picking a thumbnail, maybe you put out 1 or 2 videos a month, maybe you're just running your own YouTube channel, it's not that big of like a burden to do. But if you're like one of our giant broadcast customers where you're pumping out 3,000 videos a day, but you still maybe only have like 100 or so video staff, it gets difficult. It's the operational burden grows quickly, even though it's maybe a small task in the individual. When you group them all together, it's like we say in software, scaling concern, right? So it gets unmanageable quickly. So the question comes up, and we have this AI that can say, does that look nice? Can it do it for us? Can Archaesthetic do it for us? Can it pick some thumbnails for us? And what I want you guys to think about while we kind of talk about this process and where Temporal comes in is your iPhone, right, or your Android will pick out like featured photos for you. It's a really similar process to this, right? It's doing an aesthetic analysis on it. The big key difference, though, is that we need to make something that's like on demand, something that like they upload a video and it's just doing it right away. Whereas your phones, they have the benefit of just like, they can kind of do it whenever they want, because there isn't just a make new featured photos right now, iPhone, do it. It has background processing to its advantage. We don't. So real quick, let's look at a naive process for this. And this is super naive. So we have our inbound video. We're getting some sort of visual data out of it. I put iframes because, really, you're probably not going to be examining transitional frames because they're going to look bad. You're going to score those frames and bring back a result. And this kind of linear process, what we ran into our very first experiments is it's just kind of slow. It's too slow, and there's obviously like a lot of room for improvement too. If we have, say, 30 frames that need to be examined, well, they don't depend on each other, so they can be run in parallel, right? I think I have that, yeah. What if we did it in parallel? Got a little ahead of myself. So we modified this process, and oh, by the way, this was written in Python, and if you're asking, like, well, what architectural qualities led you to Python? Well, we built the model in Python, and then we iteratively just kept going, and yeah, we ended up with Python. It's funny how software works like that. But this is kind of a trite example here of our frame worker. So in this process, we would essentially have a piece that extracts the visual data, as arrays, embeddings, and then sends it into a multi-process queue that a bunch of other workers living on different processes would grab data from and do their analysis, and then join them all in at the end. And it worked okay. It was faster than our linear processing. But if you've ever seen like Python's multi-processing code, or honestly really any language's concurrent tool work or multi-process stuff, it can be a little arcane, a little hard to support at times, especially when you're dealing with an incident. That's the last thing I want to look at when I'm dealing with an incident is thread management or process management stuff. I just want nice logs. But the worst problem, though, is it's just too slow at this point. For 1 minute of video, this process was taking 1 minute and 20 seconds to complete. And you think about a video staff at one of these massive broadcasters, they don't have 1 minute and 20 seconds to wait for this to complete. They could have just gone and picked a thumbnail at that point. So yeah, it can find a thumbnail, but it's not useful at this point. So we go back to the drawing board here, and we examine, like, where's our bottlenecks? So like I said, this started as a naive process. And the first part of this, we actually had our video worker and our model on the same infrastructure. So we basically had to make this kind of bad compromise where our video processor didn't get what it needed and our model didn't get what it needed either. So, the obvious question is, can we just put the model on its own infrastructure? And yeah, we approached this, I think the first thing we did was we tried out SageMaker. SageMaker ended up being a little prohibitively expensive. Then we moved to PyTorch's TorchServe. And yeah, it worked out. Things got faster. Our model got dedicated tuned resources, and our video processor got dedicated and tuned resources. But it's not a whole lot faster yet. And we're still at like a 0.9 runtime, which is just not good enough, right? So, and it's getting more complicated. You look at this chart, it's crazy. We also ran into another problem at this point called the clustering problem. I like to call this the beautiful neighbors problem in video. I don't know if there's an official name for it, but essentially you can run into scenarios with a video where all of your best visual data is basically right next to each other. And that can be from a number of reasons, right? Maybe a camera was just focused on a single subject for an extended period of time. And the way that this would manifest itself with the process was the AI would just pick the same subject over and over. This example of a video, this is a homecoming video for some military service members coming back from deployment, hugging their families, laughing with their kids, really heartwarming stuff. But when you ran it through the AI process, it just picked this airplane over and over and over for every single thumbnail. And it had a good reason, that it's good lighting, it's a steady shot, the framing is great, there's 0 artifacts on it. But, there's, in this same video, there's like a guy like hugging his baby and like a mom laughing with her kid. The kind of stuff that would draw in most people, not an airplane. I like airplanes, but that's neither here nor there. So we went back and thought, like, can we segment this in a smart way, right? Can we figure out like the actual significant moments of this video and split it out that way? And our architecture grew. We now added a video segmenter. We made our frame extraction process parallel as well, because it didn't depend on each other. It's getting bigger, right? It's faster, but it's still not fast enough. 0.7 runtime, it's not quick enough. And it's more complicated. This chart is nuts, And I will warn you, it gets worse. But first, I want to show the results actually after the post segmenter. So lower left-hand corner, this is actually what a human being chose for this, and upper right-hand corner is what the model chose. And they're within basically the same second of the video of each other. And the reason why the machine chose that over the bottom one, and it's interesting, you can't even tell on the projector, but there is significant like dithering artifacts on the frame. That's the only reason it didn't choose that frame. But anyway, continuing on, let's say, classic in architecture, we get some new requirements that we maybe didn't plan for, but we probably should have. What if we need to like do some metadata stuff here, right? It's a big data pipeline. We need to do some extra metadata extraction. Well, that shouldn't be too hard, right? Just add in another process that's doing metadata saving. Oh, it needs to do it at multiple parts, though. Oh, well, now it's getting a little crazy. Pros, we got metadata, but the cons is it's confusing. Our AWS bill is climbing. It's still too slow. We added this new thing and it didn't speed it up at all. And yeah, things are not going well. And when you compound this on the fact that like we're doing like what 4,000 plus or minus videos every day, it's a lot of data, a lot of infrastructure. Things are expensive, slow, and we're basically at this point with this project where something's got to give. So let's assess really quick. What went right? The model works. We get good results. But what went wrong is the infrastructure. Basically everything around the plumbing of this, tying the model together, getting it what it needs, getting the data prepared, too slow. We have a viable product, sort of, but it's not working. So it's kind of a leap of faith moment here. Like this project needs to adapt or it's just gonna die, right? We need to mothball it or get it working the way we want. So we were already using Temporal at the post for 24/7 TV channel programming and our fast channel construction, like keeping channels in sync with each other. So it was kind of let's give this Temporal thing a shot. So this was kind of an exercise in migrating this old multi-process code over to async IO as well as Temporal, because Temporal respects the language features. If you write your stuff in async IO, Temporal executes it as if it would execute locally, which really powerful stuff. For our strategy, we kind of looked at it as like, all right, is this a thread worker? Sure, maybe it becomes an activity. Is it a process worker? Maybe it becomes an activity or a workflow in this case, depending on how much it's doing. So really quick, let's re-architect it. We re-architect, we look at our crazy chart and we think, where are the workflows in this, right? So, the first one is obvious, right? Get our thumbnails. End to end, our whole process here. But I would also say there's two kind of distinct units of works inside of this that can be their own child workflows. First one is the data preparation, and the second would be the actual inference process. So we've identified some actual concrete workflows we can run, but what about activities? And for activities, for this part, I was thinking what's kind of somewhat stateless and needs to fan out, and for that I thought the fan out stuff. So our frame extractors, our frame workers, and the metadata part, right? Making that its own activity that just kind of runs on the side saves a lot of headache. So let's look at our new chart. And this is my personal preference with Temporal. I like doing sequence diagrams for other things, but for Temporal workflows, I actually really like making them timelines. Temporal, time. That's literally the only reason I thought of it at first. But I feel it conveys kind of how they function pretty well. So we look at our new diagram. We have our parent get thumbnails. We have our data prep, our inference, and those all have activity children there. So first part of the data prep, we identify our segments. We're doing some scene detection, some secret stuff that I'm not allowed to divulge, and some metadata stuff. I know. Data prep stuff, where we're literally just going 1 to n for how many segments we identified. We're generating out our data for that. For our inference, same thing. We're ranking our frames 1 to n. And very last piece, we're taking these embeddings that we've been working with and actually sending them back into reality, making them into thumbnails and interpreting our results. So quick migration note on this, by the way. We did a hybrid of async and multiprocess at first. There's that temptation to do all or nothing, but if we went all or nothing, we probably would have never finished in a reasonable time. So we're iterative. It's not an ideal thing, but it's convenient, and perfect is the enemy of good. That's my favorite adage. And this is just kind of like a sample of what that would look like in async IO. You just run your old blocking code in an executor of some kind. So this is an example of the get thumbnails workflow, and I do apologize. This is mostly accurate. There are some omissions in here on purpose because it's an election season, and my AppSec team would throttle me if I showed you guys all the real code. So, it's pretty simple. The get thumbnails workflow is quite literally, it's just running 2 child workflows. And you see the first workflow, prepare data. It's just returning the actual parameters for the next workflow to run. And this is actually something I really like about Temporal. It really lends itself to that kind of functional, like chaining style that I really like doing in Python. And of course, the second one is the inference. The prepare data workflow. And again, this is my favorite thing about Temporal is that you're just using language features. Like nothing here is really magical. You have your workflow.run, workflow.definition, but that's it. That's the only Temporal stuff here. The rest of this is just Python. This is all in Python. So our first thing we do, we identify segments by running our get segments activity. We build out this list of coroutines where we're doing extractions over these segments. And then at the very last phase, we do our async gather. If you're not familiar with async gather in Python, it's literally just you throw a list of coroutines at it. It runs them in no particular order all at once and returns an ordered result list. And our inference workflow is doing basically the same, right? We get our list of activities, gather them up, get our results. And yeah, I mean, it's pretty simple. It's much simpler than the multi-process code from before. So as a kind of a recap, right, like the code's a lot easier to understand. Extension is way easier, right, because we're no longer, we need to extend this, so okay, let's make a new process worker. It's more like, well, let's just make a new function. Easy. And it's durable and repeatable, which, that's the theme of the conference, right? Everything is durable. But yeah, which is super important for live video workflows, by the way. I don't know if you ever worked with someone with live video, they're touchy about their live video working right, rightfully so. So, on the extension piece, I want to just this is a kind of a simple example. Let's say we wanted to enhance our interpretation pipeline of like the ranks with maybe some sentiments, maybe understand like, what is the sentiment of this segment? Does that affect our aesthetic rank here? You literally you make a new activity, get our sentiments, and then we can extend our final activity, interpret and generate, and just pass in the ranks and the segments, both as arguments. I put it in a tuple there because Temporal wants a single serializable object. But yeah, the recap that leadership likes is we reduced our costs quite a bit in this migration process. We were spending about 40 grand annually, brought that down to 4,000. A fairly big reduction in cost. And the support experience improved radically for this. We have staff at the post that they're not engineers, but they do need to support the product. And for multi-process Python code, they're sure they can jump into the AWS logs and try to suss it out. But I mean, my title is principal engineer, and I don't even feel comfortable doing that most of the time. So having this Temporal dashboard where they can actually go in and see like, well, here's where it failed, here's what went wrong. Really powerful stuff, and especially the replayability part where it's like, well, yeah, it's a big video, maybe the network glitched out and we didn't get the full artifact in. Just hit that replay button. Really, really nice stuff. And of course, my favorite, it's a way better developer experience. I'm just using Python async IO. I don't have to do any custom Celery stuff or anything like that, or if I was in Java doing like MuleSoft things. It's really nice. And also, this is kind of a side note, but what's really neat about it too is like you can actually have a Java service executing something that started in Python and vice versa. Really neat stuff. But yeah, sorry, I just have some random tips here. And some of these might be a little outdated after the discussion this morning in the keynote. We'll talk about that. But if you're doing this migration where you have these like long-running blocking things, you'll run into like this scenario, right, where like Temporal's gonna kill this, right? This will be running for 60 seconds and it won't phone home at all the whole time. Temporal's gonna be like, oh yeah, this thing died, let's restart it. So this comes from Chad Retz of Temporal. I take no credit for this code, but this is a little heartbeats decorator. You attach it to your activity function and it'll just spin off a little side thread and just send off notifications like, hey, I'm still alive, please don't kill me. Really useful for these like migration states. I don't recommend using this for an actual like non-blocking function though. Another piece here is for multi-process code, and man, that announcement about the auto-tuning for workers, Really would have loved to have that early on in this process, but this was a strange scenario we ran into where you started our process where activities were still able to spawn sub-processes, and we found we actually ran into like a ton of deadlocks with that. So my recommendation, if you have any activity that is spawning a sub-process, you want to lock your worker down to only running one activity at a time. I have these settings up here: concurrent activities, local activities, and activity task pool. Just set them all to one, and then get that code migrated away from multi-process and get rid of this. But you'll save yourself a lot of heartache this way, a lot of confusing heartache. Yeah, really quick. What's next for Arc Aesthetic? So I made this slide before the keynote went out. After the keynote, the very first thing I want to put is Nexus, because we have all these different like workflow things that are running where it would be really nice if they could talk to each other, and so that's coming next. But and the old one of our side experiments going on is like, Gen AI image assessment. There's so many generated AI images now, and I use the question like, is this image creepy? Because they can have kind of a uncanny quality to them. So that's something we're dabbling with right now, to throw in a stable diffusion image and let the model be like, yeah, this is weird looking, you shouldn't use this, don't put this on your website. Or, yeah, it looks fine, no one will notice, maybe. It does have 6 fingers, but whatever. Automated photo editing pipelines where we essentially will learn from an organization's like editing team what kind of edits they commonly do and just apply them for them. Aesthetic search, being able to search on like specific aesthetic qualities. And of course, aesthetic profile. I talked about earlier how you want to avoid like the bias of like an individual, but there actually are cases where we have customers that want like, well, actually, our like kind of general aesthetic taste is maybe a little bit different than someone else's. So can we fine tune that to us? And that's the next thing that's coming. But yeah, thank you all very much for coming and listening to me blab. I think, do we have time for questions, or hopefully? Yeah, question.
Yeah, so I have a question on the, can you hear me?
Yes.
Okay. I have a question on like the model inference workflow. So you mentioned that like part of this step is running inference with models. In that like inference activity, are you interfacing with the models through an API, or are you running like a worker that which sort of somehow that's also?
Yeah, that's a good question. So the question was basically, am I running the model like in a worker, or is there an API that's being talked to? So in this case, it actually went through both phases. The very first versions of this, we actually were trying it out with the model in the workers, and we actually ran into that same early problem that I mentioned, where it's like, oh man, we can't like fine tune this for like the model and the worker. So we went back to our approach with TorchServe, which TorchServe provides a really nice RESTful API for doing inference. So we have our own TorchServe cluster that's running, hosting the model, and then our temporal workers actually just have little clients that can go out and talk to that and get their inference on the fly. And yeah, TorchServe, that's built by Facebook and Amazon, much better at building a model server than I am, so happy to trust them with that.
So is that because like the like TorchServe is handling the like resource allocation for like from Kubernetes? Is that way?
Yeah. So the question was like, yeah, TorchServe will handle a lot of that resource allocation, resource management stuff for you, which can genuinely get pretty complicated especially when you're bringing your own model into the mix and not using like an API, which, yeah, Arc Aesthetic is our own in-house model. And yeah, good question though, thank you. Any other questions?